second. It's all good. Okay, today is May 20th, 2020. This is the Kubernetes Data Protection Working Group meeting. Today we don't have too many items in our agenda, but we have a big item to go through. Xin and me had a meeting with SigNode, Sig Storage, and another guru in Kubernetes community, Tim Hawkins, last Friday, right? Is that last Friday or no?
Yeah, Friday.
Last Wednesday.
Friday, that's Friday.
Last Friday, okay, last Friday. It was a long discussion with regarding to the execution hook design. As expected, we are facing a lot of questions and quite some pushback from Signal side to put the execution hook definition into container. And they are all reasonable questions. They are all reasonable concerns around this whole design. And then Xin and I came back with the 4 different approaches we need to look into. So from our community, the data protection working group, what me personally wanted, and Xin also probably, is to collect evidence from you guys and collect use cases from you guys to see which one exactly will meet our requirement, while if we can, we should put for a more generic solution for everybody. I'm not gonna go into too much detail over here. Xin has the design doc and she can walk you guys through. Please toast any use cases and questions around the design at any time. Again, this design is in a very early stage at this moment from my perspective. We need everybody's input to make this thing move. All right, Xin, now it's all yours.
Thanks, Shengqian. Let me share my screen. So this is the container notifier draft proposal. We went through this once. So I just want to summarize what we have proposed here before talking about what are the concerns from SigNode. So here we're proposing to add a inline pod definition for container signals and an API object to send a request to trigger those signals. And then external controller, such as application snapshot controller would be the one to send the signal and request a signal API object, and Kubernetes watches that and runs command accordingly. So this is the API. We have a inline pod definition. So we propose to add a container notifier in here inside the container struct. And this container notifier would contain a unique name. That's the unique name within a container. And then it has a handler. Handler is basically this exact action that allows you to define a command that you can run inside a container. And then also there's a timeout, like how long we should wait until we declare that it is complete, we're no longer retrying. So this is the inline definition for this container notifier. And then there's also a notification API object. So this, we have the spec. In the spec, we will have the container notifier name, so we know which container notifier we are requesting. And then there's a pod selector, so specifies which pod we should be sending this request to. And then there's this expiration second. This one basically is to more for like a garbage collection. But this is, I think there were some concerns about this option. So I think this is just something we added, but we're not sure if we want this one or not. So and then there is also status of this notification. So like external controller, like snapshot controller, send this request out, and Kubelet gets this request. It finds this container notifier, starts to run the command, and then at that point it will set this notification condition to so it's going to set this notification triggered condition type. And then once it's complete, it's going to set this notification succeeded, whether it is true or false. True meaning it's successful, otherwise false meaning it's not successful. So mainly those are the API changes that we are proposing. So we have a lot of concerns from SIG-Node. From SIG-Node side, I think the main concern, yeah.
Xin, can I stop you for a second?
Sure, of course.
I'm trying to synchronize this new design with my concerns from the old design. Is the notifications success or failure is that like the notification wasn't received at all if it fails, or is it the notification succeeded but like something that it triggered then failed?
So this one is actually something that we need to spend a lot of time discussing, because this is actually one of the main concerns. How do you define success or failure? So what we have here is the kubelet, right? It's basically watching this container this one actually, this notification object actually, right? So this is sent by a external controller. So let's say application snapshot control, let's say. So when Kubelet gets that, it's going to find this container notifier by name, and then it's going to run that command. So let's say, suppose we're trying to do a QoS, right? And then this is like you're running this command inside the container, and then it's going to return a success. It's going to return when it's complete. And then of course, if for any reason it hangs, right, I think this is something that we also talked about in our previous design. If it times out, then Kubelet can't be waiting there forever. So we do have this timeout here, which just controls how long it's going to wait. So this timeout will be like the maximum time that Kubelet is going to do, no matter how many retries it does. But when this timeout is reached, then it's going to just say, okay, we cannot finish. Okay. So at that point, it's still like the status is still false, right? It's not complete because we can't control.
Assuming it does complete, can it say that it failed?
If it completes, if it come back, and if we get an error, that is only if we get an error. Yeah, so if it time out, we also treat it as a failure, right? Because we don't really know what the status is. So
well, a timeout is a timeout, but then there's a
so
fast failure.
If it's a fast failure, then the command, when you run the command, it's going to you're going to get a failure. You're going to get an error.
Okay.
So let's say
I think we need to be, sorry, yeah. I think we need to be a little bit careful over here. I kind of know where Ben is from. Yeah. I don't think Kubelet is capable of obtaining whether an execution against the container it's a failure or not effectively, because it really depends on
it can. No, it will get right? It will get error code. If it's timeout, it's different. Let's say if it's not timeout, there is an error. It's it will get a error, and also like a message it will also get. It's just the problem is
do you expect Kubelet to understand that?
Kubelet
right?
will return.
Maybe
Kubelet will return. No, Kubelet will be watching that. They're doing the same thing for all the other
no.
type of
I think this.
probes.
I think this is exactly one of the concerns, right?
Yeah, it is. What
Who
I'm trying to say is that is the one way that we are determining. However, whether that is true or false, that's another question, right? So that's why that's their concerns is this is not deterministic. But if it returns an error, then we know definitely something happens. But if it returns success, it actually may not be really quiesced. I think that's the main problem. If it actually returns a failure, then
yeah, and I have
something
one extra layer of complexity, which is like,
okay.
Especially on the unquiesced side,
Yeah.
I believe it is important that you can return there are basically there's three possible results, right? You can unquiesce successfully and say, yep, it's back, we're back in business,
Mm-hmm.
and everything's fine. Or you can say, I failed to unquiesce and I expect you to retry because the application might still be quiesced and I need to keep trying to get it unquiesced.
Mm-hmm.
But there's a third state, which is I unquiesced, but something went wrong, and
Mm-hmm.
any snapshots that you took while you thought I was quiesced are actually bad. Like, and it's that third state that I worry
But
about.
the third state, how do you? Okay, so right now we are running this unquiesced command. How does anyone know that the snapshot is bad? I mean, I'm not getting where you're talking. What you're talking
the
about.
thing that handles the signal, it may have quiesced the application, but
okay.
it may have also unquiesced the application before you were done taking your snapshots.
Okay.
If it had like a self-destruct timer on it or something, like maybe
so
the
basically
quiesce
like
started
checking that
and then
it's already saying when it was trying to quiesce, it's oh, it's already quiesced.
No, like a quiesce can succeed, but then
right.
if you take too long before you come back and say, now I want you to unquiesce, the application may have decided of its own accord to just unquiesce itself while you were still taking snapshots. And you need to know that it did that when you come back for the unquiesce. It needs to be able to say, yes, I am unquiesced, and by the way, I unquiesced before you asked me to, so all your snapshots are bad and you have to start over. Like that is a very tricky, but I think a rather important possible.
Yeah, that's very tricky. I'm actually, I don't know how to.
Okay, let me try to understand, Ben.
So like in the original design, it was really quiesce versus unquiesce were the explicit operations that were happening. Now we've kind of genericized it so that it's pretty much any operation. And I think what's being called out here is that quiesce, unquiesce are actually special cases that we'll need to define because otherwise it gets kind of goofy.
Yeah.
So we may have
essentially, I want to make sure that the errors that we communicate back are detailed enough that first of all, the CO knows whether it needs to retry or not, because that's something Kubelet needs to know. But even if Kubelet doesn't need to retry, it's possible there was still an error that needs to get propagated to the next guy up, which is the snapshot controller, so that he knows he needs to do something. And so the error information that comes back needs to be rich enough to cover those possibilities.
Yeah, so I think that would be a challenge.
Yeah,
but I think that would be very challenging to.
Yeah, to be just to
I
be
never
clear,
said it was easy.
I'm just saying I don't even know how to how you can so basically when you start to unquiesce, you found out it's already unquiesced, then you determine that's a problem. But how do you know that's a problem? I mean, that's the thing. How do you even know? Even this is like the script, right? So you have to write an intelligence script. How the script knows
the thing that I've been
and also
about.
How do you know that's the first? How do you know that's the first one, right? The first time that you are wrong, you are being called. I think.
Yeah. So here's the case that I worry about is that some applications might be unable or unwilling to quiesce for longer than some maximum amount of time, and because of the way Kubernetes works, Kubernetes can't be relied on to unquiesce you within the time window that you request, because Kubelet can crash, other things can crash, the system can go out of quorum, all kinds of bad things can happen. So the application may take it upon itself to to decide to unquiesce when it reaches its maximum quiesce time for whatever reason.
Oh,
And,
I
and,
thought.
and the implications of that are that if someone is trying to take a consistent snapshot and they're too slow, that they're going to end up with an inconsistent snapshot. And absent any way to communicate the error back from the container up to the snapshotter, you won't know that you have an inconsistent snapshot. So you have to have a way to sort of get that signal that says, hey, I did unquiesce. You don't need to keep bugging me. You know, the application is running again, but any snapshots you took in this time window are suspect and might not be consistent. Therefore, you
So,
should.
but yeah, but the thing is, you probably just suspecting, right? You can't say deterministically that it's really bad snapshots.
You can,
right?
Here's the key. So Kubernetes has no centralized clock, right? There's no way to know that my clock matches your clock, but the application knows that if it's still quiesced at the moment you call unquiesce, that you must have taken all of your snapshots before you called unquiesce, and so it knows at that instant that, aha, I'm being told to unquiesce and I'm still quiesced, therefore I can return success all the way back up, and the guy at the top can get assurances that I didn't write any data while he was taking his snapshots. And then you know that what you have is good. But without that last sort of final handshake where you ask the application, are you still quiesced? Yes, okay, unquiesced now. And it says, okay. You don't know that the snapshots that you took in the intervening period are actually consistent.
So I think this is a really good case, and I think what would make sense here is to go back. So we've genericized this execution hook, so it can pretty much handle anything. And I would go back and take the original design for the quiesce unquiesce, make that a subset of this, and make sure that it's implementable, and then take these exact concerns for specifically the quiesce unquiesce workflow.
Yes.
Because it's not a generic problem, but it has to be implementable with this generic solution.
Yes, thank you.
So there is a, so there's one, okay, let me actually talk about the concerns from them. We can go back to this one. So,
Xin,
yeah, go
before
ahead.
you move on, I want to clarify one thing over here. First of all, the execution hook will expect your operation to be idempotent. So even if you call unquiesce multiple times, it shouldn't just fail, and the Kubernetes shouldn't just keep on retrying. That's a requirement we need to post to application owners. That's the first thing. And the second thing is that it is still doable to me because you can return a success even you call unquiesce twice. It just you need to populate the output of the unquiesce into the container notifier status, and the upper level application controllers should be capable of understand those returned strings instead of rely solely on return code. That was my thought. I think it is still achievable with this manner.
Well, if we're going to have kind of a generic application snapshotter, it needs to be able to work with multiple applications in a common way. And I think that's a good goal. I think that's like our...
Yeah, but I think that one problem is that we are not going to provide scripts, right? So that is
no,
not
but we can say how the script should work.
Yeah,
so like
that
you will
we can,
return
yes.
this code.
Yeah.
And the other thing for the unquiesce is, do we have a way to prevent multiple users from doing unquiesce?
We don't have a way to prevent
so
multiple users.
So the controller did a quiesce, and the DevOps guy went ahead and did an unquiesce operation because the database is too hung up.
You cannot prevent that.
Yeah.
Well, no, but you can. But that's something that we would want to detect at least. So, for example, like the, Ben's suggestion that if you say unquiesced and you are unquiesced, it tells you were unquiesced, and maybe even a timestamp. I don't know, but that's the kind of thing that's going to happen.
That can be in the error message, right? I think in the error message.
Right, exactly. But we should define that in like, here's quiesce, unquiesce. This is like the use case we're actually really concerned about. And how do we set this up so that we can use this? And we tell people, you should write to this spec. You should return these error codes. You can return other, more extended errors. But this is what you have to do in order to work with our next level, which is going to be kind of the generic snapshot.
That's a good point. I fully agree, and we do need an interface so that the controller can understand all these semantics. All right, sorry, go ahead.
Okay, so I was thinking that maybe we should look at this.
I got a question before we move on.
Okay.
So if there are more than one notifier, like because it's an array and you can send more than one notifier. So is there a guarantee that which one will get executed first, or is there a way to specify the priority or the sequence of execution on that notifier?
No, that we can't. It's not going to be like that because Kubelet is not going to understand your application. It's the application who is sending those requests needs to make sure that they are sent out in order. Because so you are not supposed to, so like the application snapshot controller is not going to send the unquiesce command before quiesce, and also it should not be doing unquiesce before snapshot is taken, right? So this is under the application controllers control. Yeah, Kubelet can't decide that. Yeah.
Yeah, but if I want to do some action before doing a quiesce, like maybe flush the
then you can
things like that.
Then you send another. Yeah, then if you have to do something before the I actually maybe okay. I think this might be useful, but I think I know the example. I have an example here, but this example there are some problems with this example. So if someone points out, I will explain. That this is this example, but it's just trying to say that when you're taking a snapshot, there could be multiple steps, right? So you probably look at this example already. So this is like, so I'm using MySQL database, but MySQL may not be the perfect example, but this is just to say, okay, there are a bunch of commands that you need to run. Before you quiesce, then you need to say, first you say log tables, and then you do flush disk, and then maybe you need to do fs freeze, or maybe not. So then you just need to do one after another. So you have to run the log tables first, and then you flush disk, and then you say fs freeze, right? And those kind of things you have to do like one after another. You can't like jump ahead. That just won't work. Or you can, some people, they say they just write everything, everything you need to run before taking a snapshot in one big script. Then that's possible too. You have your big script handle everything, the ordering and everything. That's another way of doing it. But then you have to at least have a pre and post. Right? Those two has to be separated, right?
Xin, I think that the question is more about the array of container notifier.
Yeah. But what I'm trying to say is like some commands you cannot combine them. So I think he's humble. I see he added some comments saying that why don't we just have like one everything together? But then I think there are certain things you can't, like especially like quiesce and unquiesce, you can't combine them. It has to be run separately.
Oh yeah, that I totally agree. But to answer Humble your question, there's no guarantee, right? You cannot guarantee that once because you don't know the order and how Kubernetes will pick up all those notifications.
All right. So if that's the case, I was just wondering, like, in which use case will have some advantage when you have a array of notifiers? Because most of the time, if you want to do some operations, okay.
Your application snapshot controller will need to be waiting for that, right? So for example, if you have to do quiesce first and then unquiesce later, then your application snapshot controller need to be waiting for the unquiesce results before it does unquiesce, right? So those type of thing you need to, it's the application controller's responsibility.
So the signal that is going to the quiesce signal is going to the kubelet, or does that get passed through to the application itself also?
So for example, if you, let's say, look at this one, right? So this is like a container. It has this script to quiesce, but this particular command, of course, will be running against your application. You want to quiesce, let's say, log tables. Of course, you have to log into the SQL database to do this log tables. Right. But it is, but it is the kubelet who is going to
issue that signal to
initiate that. Yeah.
So what if the app does not recognize that signal that kubelet is then passing through to it? How do we handle that situation?
Yeah, so if that's the case, then that's basically it's a failure, right? It can't run it. It cannot run that command, and it's failure. Couldn't basically that means it's like not found or something. It's going to be a failure when you run that command. Kubelet cannot run that command, then it should result in a failure.
And that invalidates the snapshot then?
So yeah, so that then in that case, then you should not take the snapshot. But then I think that is something, I don't know if somebody has asked this one before in our previous discussions. I don't know if this might be a good question for the backup vendors. Sometimes do people just do a best effort and then they will still go ahead and take the snapshot?
That's
I've
correct.
heard people, is that
yeah,
right?
That's correct. That's correct. So what happens is sometimes applications may not honor or participate in the quiescing activity. If we cannot achieve the best case effort, which is app consistency, you fall back to file system consistency or crash consistency. So that at least there is a backup, and those applications could sometime work with those crash consistent snapshot and recreate their data and state. And they are good at that. We believe, or at least choose to believe that. So instead of saying no snapshot or no backup, we can at least say you have a depreciated backup experience and give them the backup.
Okay, but you do need, but you want to know that you want to mark it basically. You want to have a way to
Definitely,
mark that.
we need to have a consistency level or something like that, saying if this is not app consistent, this is not file system consistent, this is crash consistent. You could have 2 or 3 levels, what we envision to achieve, and say, and flag them saying this is the consistency we could provide in this particular call because of these reasons that are logged.
I concur with that.
Okay. All right then.
Yeah, so just to come back, Xin, so we cannot have a priority defined for the notifiers. That is one takeaway. And if you need to have some operations to happen sequential ways, we have to put different notifiers or handlers.
Right.
And the kubelet has to pick it up and do the job. Okay.
Yeah.
So and the limitation is basically from the kubelet where kubelet cannot understand the priority. So there is no possibility of having it in the spec of CRD, right? That's what.
Yeah. Yeah.
But you can do multiple things in one notification.
You could, yeah, but then you write your script, right? You write I think some people actually do that. I don't know if that's the preferred way.
I would think if you have 10 different things you need to do, make one notification that calls a script that does 10 things rather than try to have 10 different notifications called in some sequence.
Yeah, so I think this probably depends on the application because some people actually prefer to do everything like just at least the pre-hook part, right? So everything like 1, 2, 3, do everything together in one big script that handles it. And then,
that really depends on application because having too many stuff in one script also poses the risk of unquiesced process.
Yeah,
complex,
you don't know. Yeah,
and the error handling very complex as well. What if it fails in the middle, etc., etc. And then, again, this is not the key of the whole concept. Really. This thing should come from whoever owns the application and knows the best of the application.
Yeah, but I think we would like to collect this feedback from backup vendors, so we can put some recommendation when we write the CAP.
And that goes back to Dave's previous comments about defining a more or less standard returning message or code. It's pretty challenging actually because it really connects to a whole lot of applications. And it has to make sense for most of them.
Yeah, so we could talk about that, but I mean, I don't know if we can ever agree on any error code. I know that we couldn't agree on that when I was working on the boarding house thing. So, so this could also be challenging, but we could try. At least we could talk about it. So I wanted. Okay, so should I talk about the feedback? So I think one of the, let me go back to go to this And actually, this is some notes from Tim. So the biggest concern from Signode is the ability to know state, because they want this one to be like bulletproof. So if you send a signal, then they want to know exactly it works or not. Not just command return succeed, but when you do quiesce, they want to really know it is really quiesced or not. So that's a big thing, because they don't want to get into a situation when something happens, then everybody says, oh, something wrong with the node, but something wrong with the kubelet, but maybe it's not. So they want this one to be clarified. So then there are several different design alternatives. I think the first one, this is what we have currently. The second one basically is this design plus a probe. So whenever you send a signal, and then you also go probe it and then make sure that the signal is not only delivered, but also you get the results that you wanted. Is it really quiesced? So that's basically will add the complexity, but I think at least this is something that we need to explore. And then a third one is make quiesce a first class. So this one, I'm not sure. I think anyway, we still need to figure out number 2, because I think even for number 3, basically, even if we just make this quiescing a first class thing, don't handle other cases, we still need to be able to tell whether it's really quiesced or not. So I think I think number 2, the second one we need to look into first.
And some of those things, like, you talk about FS freeze.
Yeah.
One of the real problems I have with the FS freeze implementation is there's no way to tell what's frozen.
Okay. Oh, the fastest. Yeah. So I think that would be something that it's good to ask the back vendor who has already done that. What is the best practice, right? We just take from them. So yeah, so if I'm thinking, so maybe I should, I just quickly put out something this morning, like this number 2, we can go through this one, because this is like this has the probe, right? So let's just look at this one. So this one is pretty much same as what we already have. But I kind of, so for this container notifier, I kind of divided this into 2 parts. So this, well, it still has this name, but then it has an action and a probe. And then the action will be the same as what we have for the container notifier today. It has this command, has a timeout, but then we also added a probe. The probe will be basically going to say, is it really in this condition, in this status that you want it to be? So basically this is like, okay, so I think something here. Okay, so basically this is like when the application snapshot controller sends this request to have this container notifier, kubelet will find this name, and then, okay, it defines this one, it has this, let's say this is a quiesce, right? Quiesce application. So it will first go look at this container notifier action, and then run that command to quiesce. And then at the same time, it will be calling this command in container notifier probe to check the status. So if it's something like log tables, I think you can actually probably check it and just try to write something and find it's okay and rewrite it. Maybe that's, that's one way of checking for at least this one. And then this way, kubelet has a relatively deterministic way to know whether it is done or not. But as you said, Dave, then maybe certain things you can't really tell, right? If it's a FS freeze, then what's this thing hands?
Well, I mean, when I looked at using FS freeze, I was considering actually writing a daemon that would run in the host and keep track of that. But it's not, just a script anymore.
Mm-hmm.
Yes. So, Shing, one question here, like, once the kubelet started to do the job and in between the pod got rescheduled to another kubelet. So are we seeing any challenges with respect to, completing that operation? or like
planning the operation.
it,
Yeah, of course, the challenges. That's why Signal is against this, right? So I think this definitely will be very complicated. You will definitely, you know, especially if you have to send a lot of signals and then, you know, the kubelet just needs to handle all of them. Definitely, I mean, will be challenging. Not saying this is definitely not easy. So we need to think through. So yeah, I don't think that's an easy answer. Yeah.
Yeah, just wondering, like, you know, will that make the applications to be, you know, kind of stuck on that particular node or kubelet due to some reason? Just wondering, like.
Your voice kind of sounds like you're talking remotely. I mean,
he is talking remotely.
Yeah, but everybody's remote. So I'm just saying his voice is far away. Like your voice is closer to the computer or something. His voice is far. I didn't get is the application what? I think there was one part I didn't get.
Yeah, is it clear now?
Yeah, it's better.
Okay, yeah. So I was just wondering, like, when the pod got rescheduled in between, when kubelet was performing some operation, will it cause the application to be stuck on that node or kubelet for some reason? Just wondering, like, something like that can pop up or not.
So you're saying it's like something happens in the middle and while you're trying to run this thing and then
Right.
suddenly, yeah. So that definitely, so kubelet restart, those are the things that we also need to consider, right? So when it restarts, then it is going to pick up. So then that means some signal could be resent, right? So that's why we have this. So that's why those has to be like idempotent. When you quiesce the first time, the second time it has to be idempotent, right? So, but you know, definitely it could be problem. You know, for certain. I think it depends on what application. For some application, your session is lost, then it's just unfrozen automatically. Yeah, so that's the problem. Then in that case, you probably just need to have to detect that and then mark that as a the degraded snapshot, something like what we were just talking about a few minutes ago, right? So,
as a matter of fact, that's actually one of the major reasons why Xin added this prop over here, right? So it's the whole imperative versus level signal triggering versus level triggering concept in Kubernetes. It goes against the concept in Kubernetes. Kubernetes relies on the state to be eventually consistent, where here is more like, oh, I send you a signal, I don't care anymore, and that's all.
but with the probe, that would kind of care, right? So if we have the probe thing, then
probe
it's a little better.
It's a little better. It's just to fix that.
Yeah.
Conceptualize, and again, that's the piece at least both of us feel that's the strongest push coming from signals. Not to say the other one is also, if you guys look at this API proposal, it's actually priority quite some change into Kubernetes itself as well as the core API. The stability of this and how powerful this thing can be scares them a little bit, because the end of the day, well, you can claim that basically people will start utilizing those notifiers to do weird things. That's one of the concerns. They don't list any like a specific use case over here, but I kind of agree with them. This is very powerful. You can pretty much achieve anything.
Yeah, that is true.
Yeah, sure. Yeah. Thanks.
Okay, thank you. Yeah, so this is does anyone have any concerns with the probe? That means it could take a little longer. It's going to do this probe. Does anyone have concerns with this approach from, I don't know. I don't know if the backup vendor want this thing to be really just quick. Does not really want to keep waiting or something. But then if we have this probe, then, but of course this one has a timeout, so we can set a timeout. So you probe it only for a certain, certain period of time. It's not like you keep probing forever. So maybe it's fine. It's not that different from what we had before. It's just, but of course the probe, for some certain things, this may not be feasible. Yeah, this is also really, I think differs, depends on what application you are.
The probe is optional, correct?
It is optional, yes, it is optional. But
What
at
does
least...
what does the probe return? About a Boolean?
So the probe is the same thing. It's basically, it's going to have this, you run a command, you will get a error code and message back. So if it's successful, then you just won't get anything, right? So then you, depending on that one. But at least this one clearly tells you this is a probe. I think from SigNode point of view, at least there's a way to say that, okay, we have tell you have to implement this probe. If you don't want to implement it, then that's, I mean, that's a different story, right? So at least this way, and there is this one there, you can somehow determine whether it is really, you have truly achieved the state that you want it to be.
So there are a number of ways that we could instantiate a probe. We could either just get a status, okay or not okay, true or false, or we could issue with the probe a structure of potential options that could indicate the status of what is there and return just one of those, or return a pointer into that struct. What is the intent of the probe?
So the probe actually, so I basically just look at how the current, like Leibniz probe, there was already some probes implemented in kubelet already. I just look at that. What that is doing is actually, it's the same. It's basically just it's basically run a command and then it comes back. So it's like, it's the same thing. It's just this probe is more, it has a purpose, right? Like the name suggests, it's probe checking. So like they have this checking whether this container is healthy or not, right? Whether it's alive or not. So that type of probe, but it's also just running some command and gets back a standard out or standard error type of thing. So it's the same thing you're getting. So it's going to be about, it's actually the same as an action. It's just the difference is the action is really something that you want to do a quest, and probe is going to check if it's really quest or not. So but the method is the same, basically.
It's not quite the same thing as checking on the execution, though, unless you're saying that, for example, during a...
Well, it's a different, it's a checking the state, right? So basically...
yeah, it's not quite the same, though, right? Because the quiesce operation may not actually, for example, have a running process that's like, I'm the quiesce process.
So yeah, so what I'm saying is, so let's say, for example, let's say if we want to do MySQL log tables, right? So the action will be, say, run that command, right? Log tables. And then your probe will be trying to write something in the SQL database and see if you can still write to it. But if it's locked, then you're not supposed to be able to write anything. Something like that. It's just,
Yeah, so I think the probe almost, if we start going down this probe route, I think that almost implies that the cancellation is something that's structured as well, doesn't it?
Cancellation, that's an unquest. You can't really, so the problem is
I understand the problem. It's like, it's like, but one thing starts to imply the other.
No,
the next question is going to be, well, I could probe it. Why can't I cancel it?
No, I don't think that cancel is not there. Not there. But if you really want to do something that, I mean, it's just, then it's not going to be something that is specifically added in there.
I'm not sure why the probe needs to be part of the structure here, rather than just saying there's another command that's defined for this execution hook that says whether or not something's running.
But why would you suggest to add? This is, of course, this is just
so like right now,
this is just really yeah?
Yeah, but like cancel and quiesce, right? We don't define this in terms of the execution hook. We say that would be part of the quiesce unquiesce protocol.
So no, so what I'm trying to, so the reason that I'm adding this one right here is because SigNode want to be able to determine exactly whether the action is successful or not, then how do you do that? You have to make sure that you run this one right after that one together. I mean, otherwise you have to define someplace out and you have to match them. How do you match them? That's
well, I want to cancel too.
Cancel, that's out of I was trying to address notes.
I would say the probe was out of scope too. I want a pony too.
So I was trying to, so their biggest concern is how do you know that you know, if it's really successful or not, right? Because when you run this command, when it hangs, then you can't even, like you're saying canceling, you may not be able to cancel it.
Yes.
That's a problem, right? So
but so you probe it and you see it's running, and then what do you do?
No, just basically tells kubelet, okay, it is quiesced. That's it. Because they want to know whether it really has achieved the goal or not.
Isn't that because what the command should do though?
Well, so the problem is then, because it could, that's what I explained, but they're saying then you can't just depend on the whatever, this is like application developer, whoever writes this type of script, right? You can't, if you tell them exactly, you say you have to do this, they may not do it. So they don't feel certain. Yeah, so it really depends on how you write your, this part, right? This script, right? How you write this one. But then if some people, they didn't do it right, and then they return success, but it's probably not really successful. I think that's their concern. So if you have
But if their command is already broken, what makes them think the probe will be implemented?
Yeah, the probe is also broken, right? That is true. I think I don't know how to. This is just this is come up in the last.
Sounds like you got stuck in the middle.
Yeah, I mean, I think I basically think the first one should do it. You just make sure that your script is written correctly. Whether it's successful or not, you should be able to do that, right? But the probe is basically, so this way you clearly calls out, okay, you have to go check the state. So I think this one, they can say, okay, there is a way here to verify that. And then the kubelet can depend on the second one to say, okay, yeah, I'm done. Now I'm truly done.
But unless that's actually being implemented by somebody we trust, they can't depend on it. So like, for example, if kubelet is able to, so for example, if the probe is your process still running? That's something that we can do from the kubelet side, right? We can say, okay, we executed this for the execution hook. We got PID X, and now we can check and see if PID X is still running or if it's hung or something. So that's something we can do without relying on the implementer. But
kubelet will know exactly what you check. That's the problem, right?
Well, you'd have to define it as like, this is actually checking to see if this process is running. Because otherwise, I mean, you're not actually solving the problem.
Well, only checking the process run is not enough. You actually want to know the
I agree.
state.
But what we're saying right now is we don't trust the implementer to do the right thing with the action itself. But we trust that if we check the probe, it'll always be correct. It's like those are two contradictory thoughts.
I think this is a way for kubelet or the SIG node to say, okay, we have to rely on your health list check. If you're not doing this health check, then.
But they're already saying we're not relying on your return value. So we're saying we don't trust your return value. But
but it's different, right? So I think the difference is this one didn't clearly cause out. If you just look at name, it's not like self-explanatory. Like this one, you look at it, okay, probe is very clear, right? I'm checking the health or something, some probe meaning we're checking something. The action, meaning you run action, you can just, you go away, you run your action. I think that's their concern. Yeah, I don't even know if this one can address the concern or not. But then that's what is called out last time. It is to have a probe, right? So the state probes. That's this option that they want. Yeah. I think it's not really what I want. It's trying to address those concerns.
But you guys see why they're concerned about this, right? They're concerned about having a very generic execution hook into the container definition will bring SIG nodes maintenance burden. basically, you're right, Dave. Basically, what they said is that, yeah, you can execute arbitrary commands against the container via this notification and notifier. And the end of the day, we are the people who will bear all the burden and look into the problems and fix any problem, or prove that the problem is not from kubelet side, it's actually from application side. You're right. And that's exactly one of the concerns. And I kind of agree with them. If there's something timeout or there's a network issue, I don't know, right? The thing is that, okay, prove me that's not kubelet's problem first before I look into that's not my problem, right? So
I'm
so
laughing
I
because
don't know.
this sounds like exactly some of the arguments I have inside VMware.
Yeah, so I don't know how to answer your question, right? So
it's not a question. I don't think I don't know. So I hate to suggest this, but maybe execution hook as a generic thing isn't doable at this point, and maybe we should fall back to like doing the actual QoS, which can be structured, where you say, yes, you need to do this. Yes, you need to do that. Yes, you need to return these error codes.
well, I agree with you as well on that. Again, I think one thing Shin didn't mention too much over here is why we're taking this API approach. There are use cases as well, which also can utilize this mechanism to signal paths, etc., so that to achieve other functionalities other than QoS and non-QoS.
I know that's where it went to, but they're not really signals, right? Signals are defined things you send, receive, and there's a way to manage these, right? And this is run a script. That's where it started from, is run a script. And now it's like, well, we want it to be more structured, but we also want it to be completely unstructured. And the two ideas are really colliding with each other. And I don't think you can do both.
You cannot achieve this via the CRD way as well, can you?
I don't know. I think you could maybe have a generic mechanism that a specific mechanism is built on top of it. Like you can have a signal or a QoS, that's defined and has a certain protocol between the hooks that it executes, and they have some stereotypical responses and stuff. But if you're going to have your kind of generic thing, I mean, you're almost getting into like designing the process API from Unix, right?
Yeah, the problem is that will require all the adapters, all the application owners to implement that.
Well, but we're kind of expecting them to, right? Because if they don't implement, so we're using the QoS, we're saying this is going to be a building block for like application snapshotter or a generic object snapshotter. And that can't be generic unless it can rely on an API that's the same. Otherwise, you're going to have 3 million plugins for it, which is just backwards, right?
But back to what you mentioned before, how do you define this if it's just the FS freeze, right? It's gonna be, we need to think more on this, but I agree with you. There are alternatives out there we should be considering, and I think Shin already considered a lot of them already.
And also FS3 is not the only thing, right? There are, the database has other comments. So even those, I think they behave differently, right? So like MySQL and Mongo, when you do the QoS, they behave totally differently.
Yeah, and even like the expectation of doing a QoS, some QoSs don't necessarily stop service. Right? You may be able to say, yeah, I can QoS you and continue to accept transactions, but I'll leave the storage alone. And I'll just write into my logs, which you don't snapshot.
Yeah.
So we're running out of time.
Yeah.
I think we do need some follow-up actions over here, because this thing it is so important to this working group, first of all, and I do see a lot of people wants it and needs it. I think one thing I would like to encourage everyone is to really share your ideas and use cases either via or working group email threads or via this document comments on this, right? We need a lot of support from you guys to move this agenda forward, right? This has been there for how much time, Shin? Maybe a year and a half?
Yeah, probably something like that.
Right. And still we don't have a very finalized idea yet. Well, the root cause is, of course, this is itself is a very complex problem to solve. And the second is really that we are lacking of use cases to support some of the points. Any comments will be highly appreciated.
Yeah, I think because
Yeah,
this
sure.
this group
So-
is the
Yeah,
go ahead.
one question from my side. Do SIG-Node see any use case with this execution hook or the container notifier, or is it just that the push happening from SIG storage side, just for maybe
No, the push is from, well, the proposal for this one pushes from SIG-Node side, but then there are some concerns for our previous design, right? So there are like many concerns.
Right.
Yeah.
But do they have any use cases defined from their end?
Use cases, I mean, you can look at it, I mean, like listed a few here, but you can actually go look at this issue. That's for those other use cases. If you can go click and go look at this issue that Tim opened a long time ago. So he would like this one to send a signal. But this is something that we can still discuss, because one of the options here is, do we just make a QoS? This is first class theme pods, right? So that's another thing. We can also, this is another thing that we can evaluate. But then,
okay.
Even for this one, I just don't see this one to be very simple, because we have like multiple. We probably still need to have like multiple notifiers even for this one. I just don't see how one is enough. So, okay. So I think we are running out of time.
Sure.
Okay, Shang-Qian, you have anything else?
Yeah. No, I need to drop off right now to have another meeting. So thanks all. Again, as I said, any comments or use cases highly appreciated. Please comment either on this doc or send via or email list. If you would like to participate into these discussions, please let me or Shin know. All right. Thanks all.
Thank you.
Thank you.
Bye.
Thanks.
Thank you,
Thank
Shin.
you.